Hi, welcome to Science Chomp. Today we're going to be looking at different groups within the periodic table. Let's start with group 1. Now, with the exception of hydrogen, from period 2 right through to period 7, within group 1, we call those the alkali metals. They're so called because when they react with water, they produce an alkali solution. For example, with lithium, lithium plus water is going to give you lithium hydroxide plus hydrogen gas. So that lithium hydroxide bit is an alkali solution, and they all react in a similar manner. So these are called the alkali metals. You've got lithium, sodium, potassium, rubidium, cesium, and francium. Their reactivity increases as you go down the group. Okay? Group number 2, they're called the alkali earth metals, and their reactivity is similar to the alkali metals. The only difference being is that they're in group 2, which means they've got 2 electrons on the outer shell, and these 2 electrons, they are lost to form a +2 ion. Now, one thing I didn't mention about the alkali metals, so that's the group 1, is that they're soft and they can be cut with a knife. Group 2 can also be cut with a knife, but they're slightly harder to cut than the ones in group number 1. So that's quite unusual for a metal. Imagine, like, if you had a lump of steel, it's incredibly hard. You can't cut it because, you know, the metallic bonding is so strong. But with these 2 groups, you can. That's quite interesting. Moving along to group number 7, we call those the halogens, and you've got fluorine, chlorine, bromine, iodine, and astatine. Okay, so these are the halogens, and they form a diatomic molecule, meaning that you have 2 atoms joined together. For example, you're going to have 2 fluorines together, or 2 chlorines together, 2 bromines together to form their molecule. Okay, they form covalent bonds with non-metals and ionic bonds with metals, and I can discuss ionic bonding and covalent bonding in another video. Moving along to group number 8, some people call this group 0. These are the noble gases, and because they have a full outer shell, they don't react with anything at all. Okay, we call them inert. Moving along to this central block, we call those the transition metals, and these are the typical metals, things like cobalt, nickel, copper, gold, that kind of thing. They all exist in this thing, and they have typical metallic properties. For example, malleable, ductile, high melting point, high boiling point, good conductors of electricity, shiny, good conductors of heat, that kind of thing. So these are the transition metals, the classical metals that we think of when we think of metals. Down here we have the lanthanides. These are highly reactive. They're called the rare earth metals, and a lot of them are paramagnetic. Paramagnetic means that when you put them within a magnetic field, they become magnetic. And when you remove the magnetic field, they lose their magnetism. So most of the lanthanides are paramagnetic. All of the actinides, which are these ones down here, all of the actinides are paramagnetic, and they're also unstable and radioactive. Okay, so these ones we call the rare earth metals, these ones we just call the actinides. They actually exist within this block here, but we don't put them there because that will make the periodic table really, really big and you can't fit them all in. Okay, well, they're the main groups of the periodic table. I hope that made sense. I didn't talk about the metalloids, but I did in a previous video. Okay, hope that all made sense, and I'll see you in the next video. Okay, bye. When water is put into a cup, it becomes the cup. When water is put into a teapot, it becomes a teapot. Be like water, my friend.